Hi there, my name is Malt. In this talk I will touch on visualization in Bundleverse. Let me jump straight into it. On the top left on the navigation panel here, you see this View tab. Click on it and you will be redirected to a page with spider plots. I'm presented with two spider plots. That's in your case, the number of spider plots could be different. Every plot shows three types of data. The green color here shows represents the data entered into the database during the last day of the mission. That's the latest entry. The green color indicates the targets I set to myself to achieve through this mission. And the mean value is the mean over the course of the mission. It's an average value for each indicator. And where is it? Over here. Yeah, this one is the mean. And the center of the plot, all data shown here are normalized in such way that at the center of the plot, it depicts the minimum value for a particular indicator, and the outer circles here, the circumference here, indicates the maximum value for the indicator. Now, if we compare mean value to the goals, as you see, on the left plot, BP here is the blood pressure. My blood pressure is persistently above the normal. Something to touch on, perhaps with the GP during the next appointment. My weight is well above the desired value. And the number of steps I'm doing per day is well below the target value. Let's have a look on the time series. There are two types of time series: normalized time series. As you see here, one plot per each state indicator. The horizontal scale is the ordering number of the measurement. It tells me that there are a little bit more than 90 dot points in this line. And the vertical scale shows a normalized value to range from 0 to 100, and the dashed line is the target value I set to achieve through this mission. Let's have a look on the raw data. The raw data shows the same indicators, but in this case the horizontal axis shows the date itself rather than the ordering number, and the vertical axis shows the units of measurements, the units which I've specified when designing this mission. Now, if you, as you see here, I wasn't doing particularly good job measuring some indicators. The social indicators, for example, I neglected to measure at all. I have started to measure number of cups I drink per day late into the mission. I gave up measuring fitness at some point, and if you look at the number of time I spent outdoors, number of hours I spent outdoors, I used to switch my timer every day I step outdoors, but then I got lazy, and at some point I just was recording those numbers late into the day, trying to remember how much time I was outside. And as you see, the statistics for this data is very different compared to those recorded early into the project. Overall, the best data I got either from was the API, the data delivered by the machine from me, or the data I was measuring with some devices like blood pressure, for example. And even in this case, when we talk about this kind of measurements, as you see here, I haven't done a particularly good job measuring my weight. Wasn't as persistent as I was hoping for. Anyway, let's jump to the correlations. The correlations plots. The correlations, in general, the correlation between, let's say we have one stochastic variable A, another stochastic variable B, and the correlation between those two variables tells us how variable B changes when we change the variable A, for example. If we increase the variable A and the variable B goes up, we say the correlation is positive. If the variable B goes down, the correlation is negative. If the variable B sometimes goes up, sometimes goes down, sometimes doesn't move at all, we say the correlation between those two variables is 0. And this correlation is measured by the correlation coefficient, and this coefficient takes values from 0 to 1 and from 0 to -1. Now on this page, every plot shows the correlation for a specific indicator. We measure it with the rest of those indicators. For example, top left plot shows the correlation between temperature and all other indicators. The next plot shows the correlation between humidity and all other state variables we measured. The colors here, the greenish color indicate positive correlation, the bluish color is for negative correlation, and the gray indicates the correlations which are not significant. Let me touch on this briefly and explain what does that mean, non-significant correlation, and where from it comes. Let's have a look. Let's have a look on this plot. Here we have horizontal scale shows the number of samples in a record. You can think of it a number of days in the mission if we assume that every day we collect one sample. The vertical axis is a correlation coefficient between two variables, say again variable A and B. And let's assume we have run mission for just only for 10 days. We have 10 numbers recorded for variable A and another 10 numbers for variable B, and let's assume those two variables A and B is 100% independent from each other. The correlation coefficient must be 0, the true value. However, if we have just only 10 samples for those variables, variable A and variable B, when we calculate this coefficient, we end up with a value something like 0.3, for example. It doesn't mean they are correlated. It means that the correlation coefficient itself derived from this data is a stochastic variable. It's a stochastic variable. It has its own mean. It has its own variance and its own uncertainty. And the shaded area here shows the uncertainty of this estimate. It shows the 95% confidence interval. If we run this estimate, if we repeat these measurements and this inference, say 100 times, roughly 95% of times, our estimate will fall within this shaded area. The uncertainty is big. It's huge because we have too little samples, too little number of numbers. The length of the record is very short in this example, just only 10 samples. However, if we increase the record, if we have 100 measurements, the uncertainty of our estimate drops down quite significantly, as you see here. And the longer record we have, the more reliable our evaluation is. Another point to make here is that the smaller the correlation coefficient we aim to derive from these data sets we are measuring, the longer the record we require to make this estimate reliable. If we are looking for correlations at the level of 0.2, and higher, we need to run our missions for about 100 days or 3 months. If we aim at the correlations of at the level of 0.1, we need to run it for much longer, for up to 1 year. Okay, that's enough. That's where from those gray columns came from. Those are the correlations which we don't trust. The record we have so far is too short to provide meaningful reliable estimates for the correlations at this level. Now, in general, when I looked on this data, I was surprised how sparse some of those plots are, how many meaningful correlations are for some of those variables. Some of them don't have none of meaningful correlations. Another point to make here interesting is that some correlations are quite counterintuitive. For example, I was feeling good, and the number of steps I was doing per day, I would expect the more active I've been per day, the better I should feel. But this data tells me otherwise. And the only way I explain it is that this measurement of how good I feel during the day is highly subjective. And this subjectivity interferes with the quality of the results we are getting here, and we should keep it in mind. I believe the most reliable data I got so far are the data sets which been measured somehow. It's the data sets either fetched for me by the API, or the data sets I've been measuring using some devices like blood pressure, for example. I believe this data that those two pressures are highly correlated with each other, and there is negative correlation with pulse. I believe that the energy I spend per day and the number of steps are highly correlated because I got it from the phone app. And the correlations between this blood pressure and weather indicators is also quite reliable. All other data sets, well, you may analyze it, them, you may try to make a story out of them, but overall, in general, they are highly speculative, I think. And that's all I wanted to share with you in this talk. Thank you very much for your time. Take care. Bye.